Good day. I'm going to discuss once again toxic substances, hazardous, and nuclear waste. What is waste? A material, substance, or byproduct eliminated or discarded as no longer useful or required after the completion of a process. Waste is any unwanted or discarded material we produce that is maybe solid or liquid or gas. It may be toxic or maybe not. Introduction. The US Environmental Protection Agency estimated that US factories release 1.8 million metric tons, about 2 million tons of toxic chemicals into the air, land, and surface waters in 2011, including a number of chemicals that are known carcinogens in the United States. Hundreds of billions of gallons of ground water are also contaminated with uranium and other toxic chemicals. And more than 63.5 million metric tons, about 70 million tons of radioactive waste, which is mostly uranium waste derived from spent nuclear fuel, is buried in landfills, trenches, and unlined tanks. Differences between toxic and hazardous waste. A substance will be hazardous waste if it is reactive, corrosive, flammable, or ignitable, toxic. A toxic waste is only waste that when ingested or absorbed is harmful or fatal to living organisms. So hazardous waste may be sometimes toxic, but toxic waste always be hazardous waste. Hazardous waste are poisonous byproducts of manufacturing, farming, city septic systems, construction, automotive, garages, laboratories, hospitals, and other industries. The waste may be liquid, solid, or sludge and contain chemicals, heavy metals, radiation, dangerous pathogens or other toxins. Even household generate hazardous waste from items such as batteries, used computer equipment, and leftover paints or pesticides. Examples of hazardous waste: car batteries, pesticides, light bulbs, used motor oils. Management of hazardous waste. There are two approaches: common management and sustainable management. So this is actually the pyramid. The topmost is the most favored option, and the base of the pyramid is the least favored option. Top of the pyramid is the prevention, then succeeded by minimization. Next is reuse, recycling, energy recovery, and finally, disposal. Sources of hazardous waste. Toxic waste results from industrial, chemical, and biological processes. Sources of hazardous waste. Number one is byproduct of industrial and domestic activities. Second is mining sites and mineral processing sites. Third is agricultural facilities and research laboratories. Number four is all sources that discharges liquid, solid, and gas that fit the definition of hazardous waste can be regarded as hazardous waste. Number five, agricultural land and agro-industry. Number six, contaminated sites and building materials. Examples of common hazardous waste include waste oil and fuel. Number two is solvent and thinners. Number three, toxic and flammable paint waste. Number four, chlorinated solvent, heavy metals. Number five, perchlorates and peroxides. Number six, radioactive waste, etc. Hazardous waste have four categories. Number one, listed waste that EPA has determined are hazardous, and listed include depth list, waste from common manufacturing and industrial processes. K-list, waste from specific industries, and P and U-list, waste from commercial chemical products. Number two, characteristic waste that do not meet any of the listings above, but that exhibit ignitability, corrosivity, reactivity, or toxicity. Number three is universal waste, batteries, pesticides, mercury-containing equipment, such as thermostat and lamps. Example are the fluorescent bulbs. Mixed waste that contain both radioactive and hazardous waste compound. Types of hazardous waste. Hazardous waste may be of two types: designated waste or listed waste. Characteristic waste, designated waste in one that is specifically listed by US EPA as hazardous, while characteristic waste is one that exhibits any one of the characteristics of ignitability, corrosiveness, reactivity, and toxicity, or waste that do not meet any of the listings type waste but that exhibit ignitability, corrosivity, reactivity, or toxicity. Designated waste or listed waste types. EPA designates more than 450 listed waste, which are specific substances or classes of substances known to be hazardous, classified into four groups or listed. Number one, F-type, waste from non-specific sources. Number two, K-type, waste from specific sources. Number three, P-type, acute hazardous waste. Number four, U-type, miscellaneous hazardous waste. Types of listing type waste. Number one, F-type waste, non-specific waste, because the processing produce this waste can occur in different sectors of industry. The F-listed waste are known as waste from non-specific sources. For example, the list identifies waste from common manufacturing and industrial processes, such as solvents that has been used in cleaning or degreasing operations. Number two, the K-list, source-specific waste. The K-list source-specific waste, this list includes certain waste from specific industries such as petroleum refining or pesticide manufacturing. Certain sludge and wastewaters from treatment and production processes in these industries are examples of source-specific waste. P-type acute hazardous waste, waste that have been found to be fatal to humans in low doses or capable of causing or significantly contributing to an increase in serious irreversible or incapacitating reversible illness. For example, these are mostly specific chemical species such as fluorine, or known as PO56, or 3-chloropropene nitrile, known as PO27. U-type miscellaneous hazardous waste, a variety of waste are listed here. These are predominantly specific compounds such as calcium chromate, known as UO32, or phthalic anhydride, known as U190. Characteristic waste. Environmental Protection Agency defines this hazardous substance in terms of the following characteristics: in terms of ignitability, corrosivity, reactivity, toxicity. Ignitability. Ignitable substance in this waste may be liquids, gases. They catch fire due to presence of ignition source or the liquid, from friction or contact with water, non-liquids, ignitable compressed gases and oxidizers, organic peroxide. Corrosivity, characteristic of substance that exhibit extreme acid to or basicity or tendency to corrode steel. Example is the HCl, others. Reactivity, substance that have a tendency to undergo violent chemical change. Examples are explosive, pyrophoric material, water reactive substances, or cyanide or sulfide bearing waste. It is a cyanide or sulfide bearing waste which, when exposed to pH condition between 2 and 12.5, can generate toxic gases, vapors, or fumes in a quantity sufficient to present a danger to human health or the environment. Toxicity, substances which are itself toxic or its compound are toxic. Example is the arsenic, D004. We have the EPHW number 1. So on the topmost row, this is D004. The contaminant is arsenic. Under the next column, CES number 2, it is categorized as 7440-38-2. The regulatory level under the milligram per liter is 5. Next is D005. The contaminant is barium. CES number 2, categorized as 7440-39-3. Its regulatory level is 100. D018, benzene, CES number 2, 71-43-2. Regulatory level is 0.5. Next is D006. Contaminant is cadmium. CES number 2, 7440-43-9. Regulatory level 1. Next is D019. Carbon tetrachloride. CES number 2, 56-23-5. Regulatory level is 0.5. And lastly, D020. Contaminant is the chlordane. CES number 2, 57-74-9. Regulatory level is 0.03. The industries which produce hazardous waste are petrochemicals, pharmaceuticals, pesticides, paints and dyes, fertilizers, asbestos, caustic soda, inorganic chemicals, and general engineering. Type of hazardous waste: nuclear waste. Nuclear waste is a radioactive waste left over from nuclear reactors, nuclear research projects, and nuclear weapons. Nuclear waste is divided into low, medium, and high level waste by the amount of radioactivity the waste produces, although nuclear waste can be very dangerous and should not be handled by anyone without professional training. Low level waste. Low level waste is generated from hospitals and industry as well as the nuclear fuel cycle. Low level waste include paper, rags, tool, clothing, filters, and other materials which contain small amounts of mostly short-lived radioactivity materials that originates from any region of an active area are commonly designated as LLW as a precautionary measure, even if there is only a remote possibility of being contaminated with radioactive materials. Intermediate level waste, abbreviated as ILW, contains higher amounts of radioactivity compared to low level waste. It requires shielding but not cooling. Intermediate level waste include resin, chemical sludge, and metal nuclear fuel cladding, as well as contaminated materials from reactor. Decommissioning, it may be solidified in concrete or bitumen for disposal. High level waste. High level waste, HLW, is produced by nuclear reactors. The exact definition of HLW differs internationally. After a nuclear fuel rod serves one fuel cycle and is removed from the core, it is considered HLW. Fuel rods contains fission products and transuranic elements generated in the reactor core. Spent fuel is highly radioactive and often hot. HLW accounts for over 95% of the total radioactivity produced in the process of nuclear electricity generation. Electronic waste. Electronic waste, e-waste or e-scrap or waste electric and electronic equipment known as W and AAA. Describes loosely discarded, surplus, obsolete, or broken electrical or electronic devices. Environmental group claim that the informal processing of electronic waste in developing countries cause serious health and pollution problems. Some electronic scrap components, such as CRTS, contain contaminants such as lead, cadmium, beryllium, mercury, and brominated flame retardants. Medical waste. Medical waste are hazardous. It definitely can cause health problems if it is not properly managed. Discarded needles and blood products have the potential to spread diseases and cause injury. Most medical waste streams are regulated at the state and local level. So these are known to be the biohazard. Construction waste. Waste from construction sites can be hazardous. Asbestos tiles and insulation, lead pipes, and certain chemical used in maintenance all fall into this category. The construction industry need to be aware of these hazards and vigilant in their safe disposal. In industrial waste, many cleaners and solvents used in industrial and commercial processes become hazardous waste after used. These include wood preservation, chemicals compound and contain toxin, and refinery. So wastewaters also, pharmaceutical manufacturing and organic chemicals production also lead to the creation of hazardous waste. Largest source of unregulated hazardous waste, what harmful chemicals are in your home. Cleaning, disinfectants, drain toilets, and window cleaners, spot removers, septic tank cleaners, paints, such as latex and oil-based paints, paint thinners, solvents, and strippers, stains, varnishes, and lacquers, wood preservatives, artist paints, and inks. General, dry cell batteries, mercury and cadmium, glues and cements. Gardening, we have the pesticides, weed killers, ant and rodent killers, flea powders. Automotive, gasoline, used motor oil, antifreeze, battery acid, solvents, brake and transmission fluid, rust inhibitors, and rust remover. What can you do at all? What can you do? Hazardous waste is to reduce. Use pesticides in the smallest amount possible. Refuse to use toxins. Use less harmful substance instead of commercial chemicals. For most household cleaners, for example, use liquid ammonia to clean appliances and windows, vinegar to polish metal, clean surfaces and remove stains, and mildew, baking soda to clean household utensils, deodorize and remove stains, borax to remove stains and mildew. Dispose of properly. Do not dispose of pesticide, paint, solvent, oils, antifreeze, or other product containing hazardous chemical by flushing them down the toilet, pouring them down the drain, burying them, throwing them into the garbage, or dumping them down storm drains. Hazardous waste strategies. Prevention is better than disposal or cleanup from cradle to grave. Bioremediation with bacteria. Phytoremediation with plants. Incineration. Deep well disposal. Surface impoundments. Secure landfills. Toxic waste is waste material that can cause death, injury, or birth defects to living creatures. It spreads quite easily and can contaminate lakes, rivers, and the atmosphere. The term is often used interchangeably with hazardous waste or discarded material that can pose a long-term risk to health or environment. Examples of toxic waste: dioxins, produced by burning chlorine-containing substances, plastics, the manufacture of iron and steel, and some organic chemicals. Heavy metals, widespread industrial use such as in cadmium, nickel plating found in batteries, mercury, cadmium, lead, and leaded petrol. Reactive waste, byproduct of nuclear power generations and used in medicine, example, cancer therapy. Management practice of hazardous waste. Hazardous waste management strategy. Waste minimization. detoxification and neutralization of waste by treatments, destruction of combustible waste by incineration, solidification of sludge and ash from step 2 and 3, disposal of residues in landfills. So this is under solid waste management. Management practice of hazardous waste, waste minimization helps in resource conservation, economic efficiency, and environmental protection. The strategies include source reduction, recycling, and waste exchange. Treatment methods, physical, chemical, and biological treatment. Incineration. Incineration is the disposal method in which solid organic waste are subjected to combustion so as to convert them into residue and gaseous product, able to achieve 99.99 destruction and removal efficiency of hazardous component in waste. Primary products are CO2, vapor, and ash. Sulfur-bearing waste gives off SO2, CO2, H2O when incinerated. Byproducts of incomplete combustion are sometimes more harmful. Two types of incinerators: liquid injection system and rotary kiln. Solidification or stabilization. Convert the waste into insoluble, rock-hard material. Additive materials used to reduce the mobility of pollutants in the waste. Certain materials like nickel cannot be destroyed or detoxified by above methods. The residues that are left out of solidified to reduce the leachability. Number 5, disposal methods. The options for disposal include land disposal, underground disposal, and deep well injection. The source of disposal method should be based on evaluation of economic and potential pollution risk. To prevent environmental pollution from landfills, it is essential that sites are taken into account. Sustainable management of hazardous waste. Alternative of that disposal method assures both economic and environmental benefits. So you can see that the pyramid: source reduction, recycling and composting, conversion technologies, landfilling. This is the hierarchy of preferred solid waste management strategies. Then the paradigm shift from source reduction, recycling and composting, conversion technologies, and landfilling is the paradigm shift for the 21st century, which is actually expressed in an inverted pyramid. So you can see here the cycle for the sustainable management of hazardous waste. So under the waste management. So we need to reuse, recycle, and reuse. Sustainable management of hazardous waste. Buy foods with less packaging. This will reduce. Bring your own bags for carrying groceries. No paper or plastic. Bring your own bottles or cups. Look for products that use fewer toxins. If choosing between glass, metal, or plastic, choose glass or metal. Preferred packaging hierarchy: no packaging, minimal packaging, reusable packaging, recyclable packaging. Compose your yard waste and kitchen scraps. If using plastic, use photodegradable or biodegradable plastic constructions. Don't go away completely. May add toxins to soil. Never decompose in sanitary landfill. People may think littering is okay. Sustainable management of hazardous waste, reuse or resell things that are still good, auto parts sold through junkyard, the manufacturing, salvage parts, doors, stained glass from old buildings. Some areas provide money to return bottles for refilling. Donate clothing or toys to charities that will sell them for money. Preferred over recycling because material doesn't have to be reprocessed. Under sustainable management of hazardous waste, recycling is a resource recovery practice that refers to the collection and reuse of waste material such as empty beverage containers. The material from which items are made can be reprocessed into new products. Yes, you need to decompose the leaves. So on your garden, just provide there an area where you can actually decompose the vegetables coming from the kitchen, and let us go green for the waste bin. So we need also to avoid cutting trees as indicated here in our presentation. Impacts of toxic waste. The effects of toxic waste can impact individual health and the environment. The consequences of poorly disposed toxic waste can impact the environment long after its effect on individuals. Pollution. So, number one, water pollution. Water pollution is the contamination of water bodies. Water pollution occurs when pollutants are discharged directly or indirectly into the water bodies without adequate treatment to remove harmful components. Effects of water pollution: death of aquatic and water animals, disruption of food chains, disease, destruction of the ecosystem. So these are actually common in industrial sites, toxic waste, and environmental loss. Water Prevention and Control Act, year 1974. The objectives of Water Prevention and Control of Pollution Act are to provide for the prevention and control of water pollution and the maintenance or restoration of the wholesomeness of the water for the establishment with the view to carrying out the purpose aforesaid of boards for the prevention and control of water pollution, for conferring on and assigning to such boards powers and functions relating thereto, and for matters connected therewith. Hazardous Waste Management and Handling Amendment Rules, year 2003. These rules classify used mineral oil as hazardous waste under the Hazardous Waste Management and Handling Rule 2003 that requires proper handling and disposal. This is actually an environmental law. Hazardous Waste Management and Handling Rules, year 1989. Hazardous Waste Management and Handling Rule in 1989 as amended to date were notified in the country under the provision of the Environmental Protection Act of 1986 for management and handling and import of hazardous waste into the country. These rules were amended in the year 2000 and 2003 to bring the rules in line with the requirement of the Basel Convention and also to improve the applicability. Ozone depleting substances regulation and control rules 2000 MOEF VIDE, its notification date 17th July 2000 under the sections of 6, 8, and 25 of the Environmental Protection Act of 1986 as notified rules for regulation or control of ozone-depleting substances, known as ODS, under Montreal Protocol. As per the notification, certain control and regulation has been imposed on manufacturing, import, export, and use of this compound. National Environmental Policy. The National Environmental Policy of the year 2006 has brought out management aspects of hazardous waste in the form of an action plan which includes develop and implement viable models of public-private partnership for setting up and operating secure landfills, incinerators, and other appropriate technique for the treatment and disposal of toxic and hazardous waste, both industrial and biomedical, on payment by users, taking the concerns of local communities into account. So we need to go green. Under Republic Act, under the Congress of the Philippines, Metro Manila, 8th Congress, Republic Act number 6969, October 26, 1990, an act to control toxic substances and hazardous and nuclear waste, providing penalties for violations thereof and for other purposes, be it enacted by the Senate and House of Representatives of the Philippines in the Congress assembled. Section 1, short title, this act shall be known as the Toxic Substances and Hazardous and Nuclear Waste Control Act of 1990. Section 2, declaration of policy. It is the policy of the state to regulate, restrict, or prohibit the importation, manufacture, processing, scale, distribution, use, and disposal of chemical substances and mixture that present unreasonable risk and or injury to health or the environment, to prohibit the entry, even in transmit of hazardous and nuclear waste and their disposal into the Philippine territories limits for whatever purpose, and to provide advancement and facilitate research and studies on toxic chemicals. Section 3, scope. This act shall cover the importation, manufacture, processing, handling, storage, transportation, sale, distribution, use, and disposal of all unregulated chemical substances and mixtures in the Philippines, including the entry, even in transit, as well as the keeping or storage and disposal of hazardous and nuclear waste into the country for whatever purpose. History of worst nuclear disasters. So, worst nuclear disasters in history. Chernobyl, April 26, 1986, built in the late 1970s, about 65 miles north of Kiev in the Ukraine. The Chernobyl plant was one of the largest and oldest nuclear power plants in the world. What happened? A sudden surge of power during a reactor system test destroyed Unit 4 of the nuclear power station. The accident and the fire that followed released massive amounts of radioactive materials into the environment, a test to see how a plant would operate if it lost power. The Kishtom disaster was a radioactive contamination accident that occurred on 29th of September, year 1957 at Mayak, a plutonium production site in Russia for nuclear weapons and nuclear fuel. Processing the plant of the Soviet Union. What happened? A radioactive contamination accident. The final death toll of the Kishtim disaster can never be known. However, a number of independent sources claim that fatalities must have been upward around 10,000. not by the explosion and the initial exposure alone, but due to a long period of toxic poisoning, both prior to and for decades after the event. 3 Mile Island, March 28, 1979. The 3 Mile Island accident was a partial meltdown of reactor. Number 2 of 3 Mile Island Nuclear Generating Station, TM1-2 in Dauphin County, Pennsylvania, near Harrisburg, and subsequent radiation leak that occurred on March 28, 1979. It was the most significant accident in U.S. commercial nuclear power plant history on the 7-point international nuclear event scale. The incident was rated a 5 as an accident with wider consequences. What happened? A cooling malfunction caused part of the core to melt in number 2 reactor. The TM1-2 reactor was destroyed, and subsequently radiation leak March 28, 1979. Some radioactive gas was released a couple of days after the accident, but not enough to cause any dose above background levels to local residents. Wind scale, October 10, 1957. The wind scale fire of October 10, 1957 was the worst nuclear accident in Great Britain history, ranked in the severity of level 5 out of a possible 7. On the International Nuclear Event Scale, the fire took place in Unit 1 of the 2-mile wind scale facility on the northwest coast of England in Cumberland, now Sellafield, Cumbria. The 2 graphite moderate reactor, referred at the time as piles, had been built as part of British post-war atomic bomb project. Wind scale pile number 1 was operational in October 1950, followed by pile number 2 in June 1951. What happened? A routine heating of number 1 reactor graphite control block got out of control, causing adjacent uranium cartridges to rupture. So here are the pictures of the calamities that happened to the nuclear sites. So even children already have deformation. This is because of the alteration of their genetic structures. So these are the ill effect of these toxic substances caused by these nuclear substances. Children of Chernobyl, they provided here some sites in which they would actually care for these children. So they need to contain the ill effect of these toxic substances by providing here precautionary measurements. This ends the presentation.